This slidecast will cover namespaces and visibility. Now, the entire C++ standard library is contained in a namespace, std, and a namespace is a way to group collections of declarations into a functional unit. And we can use namespaces so that clashes between duplicate names are avoided. Now, suppose we have an adventure game program where we define a class map that represents the area where the action takes place. Now, the standard library already defines a class called map, and it associates values with keys. This is one of the data types that we'll cover in Chapter 9 this semester. Now, in order to avoid a clash between the two map classes, or to make it clear which definition we're referring to, we can prefix the namespace name before the class name. Here's a declaration of a map class, and it uses the standard map as a component of one of its data fields. So this data member, the map, its type is the standard library's map class. Now, I could make the distinction even clearer by defining my own game namespace and putting my definition of my map class within that namespace. And then when I declare variables of these two different kinds of maps, I specify the namespace along with the name of the class, and this is so I can clearly designate which type I'm referring to. Here is the syntax for namespaces. So it's the keyword namespace, followed by the name of my namespace, and then all the definitions would be placed between the braces. And here's an example of the game namespace. Now, namespaces, they're open so that you can have more than one namespace declaration with the same name in your program, and all the identifiers in the different declarations are all merged into a single namespace game. Namespaces are nested. We have a global namespace at the top level, and its name is effectively the null string. So in our map example, this would refer to the standard library's map, and this would refer to the map that I declared in the global namespace. And since the reference to it is made within this global namespace, I can leave off this leading prefix. If I defined a game namespace but I didn't define the map class in it, then code within the scope of the namespace game that referenced my class map that was defined in the global namespace, then it would require this prefix qualifier. So this would signify the definition of map in the global namespace. Now, here's some code that declares a map class in the global namespace, and here's one in the namespace game. So this statement in the global namespace would declare an object map1 of type map. That's the map that's defined in the global namespace, and this statement would declare an object of type map, the one that was defined in the game namespace. Now, these statements are within the game namespace. Map4 is of the map class that's declared in the game namespace, and map5 is the map that's declared in the global namespace. Now, the using declaration takes a name from the namespace in which it was declared and places it in the namespace where the using declaration appears. Here's an example of a using declaration, and the name cout is now a member of the namespace in which the using declaration appears. And this using directive can take all the names from a given namespace and place them in the namespace where this using directive appears. When I have a statement like this where I use the namespace std, then all the names defined in the standard library are now defined as such within the current namespace. Now, here are the visibility designators in C++. Private means the visibility is only within this class. Protected is visible to classes that extend this class. Public is visible to all classes and functions. The friend declaration allows a function external to a class to access the private members of that class. And it gives functions and classes that it specifies access to the private and protected members of the class in which the friend declaration appears. So this effectively makes the named function or the class a member of the declaring class. Now, a class must declare who its friends are, and this friendship is not inherited, it's not transitive. So if a base class is a friend of a particular class, its derived classes are not automatically friends too. They would each have to be declared to be friends. Now, here's an example. We have a class A with a data field X, and it declares that foo is a friend of A. Now here's function foo, and it declares a local variable A that's of type class A, and here it makes an assignment to that data member A, and this is valid even though notice that X is a private data field in A. Because foo is a friend function, then it can access the private members of A. Now here's a function bar that also declares a local variable of type A, but it's not valid for it to reference a private data field because this isn't a friend function. Here are three classes, A, B, and C. A declares B to be a friend class, and B declares C to be a friend class. So when function foo within class B references the private field in A, it's legal because B is a friend of A. And similarly, when this bar function in class C references a private field in B, that's legal because C is a friend of B. But this is not valid to reference a private field in A within class C because C is not a friend of A. This is the end of this slidecast.